Hello, welcome back. Last time I did subsequence extractor, which was pretty cool, and then signal prescaler, which was super cool because I got to implement bit shifting in a pretty interesting way. That was a great time. So I keep talking about these things that have been emailed to me. So I have this here. I've gone ahead and input sequence range limiter and both solutions I got for sequence merger and also the one for sequence sorter. But I'm not going to look at them just yet. I'm not quite in the mood to pick apart somebody else's program. I want to write a new one. This has an incredibly wide variance of cycle counts, like even more extreme than this. So there's a very, very, very slow way to do this, apparently. Pretty wide range of node counts, too. Like for nodes, that's a big spread. Okay. What the heck is this going to look like? Read values from A and B, write average, and be rounded down to out. Average, got it. So, to express this in a high-level language, it would be out equals B minus A divided by 2 plus A, would be the easy way to write that. But in this language, it's going to be a lot more complicated than that. Maybe it's Wi-Fi, and we're just not seeing the SSID Wi-Fi, and we're just not seeing the SSID. Wi-Fi? Yeah, like a dark Wi-Fi or something, then over the internet. Internet? You know what I mean? No. This is strongly giving me the sense that time travel is going on here. This person is living in the present. This person is living in the past, possibly. Okay, so all I have to do is a divide by 2, and I just saw a way to do that with bitwise decomposition. Okay, sure. So let's extend what I did for this in order to do that, right? Right? So, well, yeah, sub-right from what? Alright, so I'm feeling like it's going to be something like that. Probably not exactly that. Sure, so here you get a number that you want to divide by 2. Now, remind me how my decomposer worked. I think I kind of remember, but let me just look at it again. So you first take the actual number, then you read a sequence of bits, or like bit-shifted values that you can add together that represent each bit in it. Add them together if... No, you subtract them, and that's your decomposition. Okay, right, so numbers to subtract. Yeah, that's how it is. So there's a bit table. There's a thing that stores and moves values around, and then the thing that actually subtracts each one and signals whether the bit is set or not. Then there's the recomposer and the recomposer's bit table. Okay, so that's 5 nodes to do all this. That's totally fine. And annoyance is you. So my bit table's probably going to go someplace else. All right, so the so in order to capture all 3-digit decimal numbers, I have to start with 512. Can I put the bit table here? I don't know. Let's pretend I can and type it out. 128, 64, 32, 16. What am I doing? Divide by 2. If it's a divide by 2, then I do need all of the intermediate values here, all the way down to 2. I don't have to go to 1. 4, here, this is how I do this. 2, and I'm already at 2, so I don't need to. Okay. So move all the bits. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 bits. Now, you need to receive this number. And... well, okay, so you need to hang on to it. I'm going to need... wait, do you need to hang on to it? Why? No, this is not how this works. Hold on, right, so there's an right, since I don't have enough space to move each bit twice. That's why there's an intermediary between the bit table and the thing up there. Because you're just a value duplicator. So you sub down JLZ bit not set. Add down. If you haven't done that, you just want to discard that value. And you want to and you need a counter so you know how many bits you're doing right. Hang on, let me just look one more time at this. I could do some copying. Move 9 down. Yeah, so there's the 9. I'm also doing 9 bits here or something. Well, no. 1, 2, 3, 4, 5, 6, 7. Is this a signal? Finish. That's probably a signal. Hang on, how do you know how many... oh, you get a... okay, you get a signal at the end, so it doesn't actually count, it just waits for a negative number, of course. Okay, sure. That was all I needed to see. So, sub down... wait, I can't do that, can I? How did I handle the idea of... J-row up? Oh, that's a J-row value, got it, right. Yeah, that was how it is. Okay, I remember. Gonna be doing a bunch of jumping back and forth between those, I think. So this is awkward. So that was why the intermediary between the bit table and the other thing had more code in it than, you know. But let's just see how far I get with this. So this is a J-row value. J-row down. Sub down. Okay, so you're going to send 1 if it is not less than 0. So 1 will take you there. You'll subtract that. If it's less than 0, then bit is not set, so you add the down, otherwise you discard it. Okay, and also you need to send a bit signal to this. To this. So you're going to be my recomposer. You're going to be my bit table. At some point you'll add up. That'll be like the last thing you do. Yeah, so all the way at the bottom will look like that. If bit not set, then just move. Let's do a J-row for this. Okay, so let me do this before I set up my signaling for that. But hang on, something's not done here, right? I wonder how J-row handles empty lines. Like if I J-row 1, does that go here or here? Well, it doesn't make a difference. Well, okay, but then if I go 2, Does it go here, or does it go here? I don't know. Not going to investigate now, because empty lines are not actually interesting. I will not leave any in my finished program, other than, like, at the end. Anyway. So if you are negative, if you're ending... Oh, then that's just -1. Yes. Okay, that's just -1 in that case, right? Or maybe it's all the way down here where you move... Well, no, you never move that value anywhere. Like, again, this value gets decomposed, and a divided by 2 version of it comes over here. Gets recomposed here, then you add the up. I have these reversed. That's annoying. Well, check it out. There we go. Easy. If I'd flipped this horizontally, maybe I would have had an easier time with this. Right, it's b minus a, not a minus b. That's fine. B minus a. So that's fine. Except it's not, because the a needs to be added back in. So I do need to flip this horizontally, don't I? Whoops. All right, that's fine. I can do that. Okay. Although the output is here. Does that change anything? Maybe. Well, no, I mean, this is okay. I can have this all work without flipping it, I think. Yeah, I'm going to work with this layout that I started with. It's fine. Okay, so you get the actual value, and you want to decompose it and send the decomposition over here. Okay. Bit set, bit not set, or something. Sure. So your J row is going to be either 1 or at the end do something. This is going to be either 1 or 1, 2, 3, 4, 5, 6, 7, 8, 9, just like the other one. Okay, sounds reasonable. Sure. This label's just so I know what's going on. No, it's not. No, that's actually used. What am I saying? Anyway, right. So this label's just so I know what's going on. So right, I need to write U so that I know what instruction offsets to use with this. So what are you doing? You're recomposing bits. All right, so I need to copy this, delete that. Oops. So here is where I'm doing my divide by 2. There, I just divided by 2. Although these all need to be lefts. There's no search and replace, unfortunately. Is there? No, Control F does nothing. First time I've wanted one in this editor. Kinda weird to want such a thing in this situation. Alright, so you want to just J row left. Right, I can't new line because all the lines are already there. Here, let's just, yeah, that's what's going to happen last. I need to be able to insert lines. Technically, you don't need to do that first. That can be after this. No reason to do it up front. So either you add right, loop is J row left, or you skip, which would be a 0. So you either J row 0 or J row 1. All right. So if bit is set, then you get 1. If bit is not set, then you get 0. Okay. And if ending, then you get 3, right? Sounds surprisingly sensible. Thing is, though, add up. That's not what you do. You need to add left. Okay, sure. I think that's all. Is this done? I really doubt it. But maybe I'm wrong. Okay, I'm not wrong. Something is not working here. You have 508. That's not the correct value. You're trying to move that. You want to move a 1 to the up, but you're waiting for this. Move up right. Oh, wait, move up right. That's not right. You need another one of these, I'm pretty sure. Because... Ooh, no, false. You need to do something different. Oh, that's annoying. So my whole thing where I needed to flip horizontally, I need to save this value. And I can't sub ACK. Why not? Sure I can. Watch this. I can totally do that. Check it out. Neg. Add right. There we go. So I saved this in here. I subtracted right from it by doing this. Or subtracted it from right, rather. And then I move ACK down. Then I swap. Then I move ACK down. Okay. Did I phrase that right? So I read the low value. Oh, okay. Oh, no. There isn't a low and high. Oh, I need to... Okay. Now, hang on. This is okay. I can just swap these around. Okay, so there's an initial step to figure out which is the greater and which is the lesser value, and order them that way. Okay, so right, averaging can go both ways. All right, that was an important observation to make. I only looked at the first sample, then wrote my entire code before looking at any of the others. That's fine. Okay, so you need to know... save is fine, sure. Let's... I'm definitely going to have to read that twice. I'm going to subwrite if am I thinking of this right? Yeah, so if less than 0, then right is greater, RG. If right is greater than... Yeah, if right is not greater, then I just want to swap. However... Okay, I see how this is going to work. Okay, this is silly. Is it? No, how is this going to work? I know what I want to do. It's just there's kind of a tangled mess here of like half-written program. There are 2 half-written programs here, and I've lost track of which half is which. So I'm going to read the left side. Save it and back. Sure, reasonable, because otherwise I'll lose it, kind of. I mean, strictly speaking, I won't, because I can reform it with this. But anyway, I won't worry about that yet. Sub-right, which is saved to... Okay, so you have this value that's non-fragile. And you have this value that's non-fragile. Okay, so at this point, I have the left value in your back buffer, safely saved away. I have the right value in your front buffer, safely saved away. So that's fine. I'm not losing either one. Then I do the comparison. So if my comparator says that right is greater, I don't know if I want to neg yet. I don't know if I don't want to neg yet. If the comparator says left is greater, then I swap. Swap is wrong, or at least incomplete. Move up ACK sub right. Well, I mean, what I do here depends on what I want to do with the values after that. I want to subtract the lesser one from the greater one. So I think what I probably want to do is... Yeah, I'm going to have you tell you what the greater value is. And then you're just going to hold on to it for a second in your I/O port and spit it back over here when I want it, right? Something like that. But you're being told what the greater one is. You never actually... This doesn't go anywhere. That's a nothing. Yeah, okay, because I had done this. Okay, this was actually where my unfinished program was. I see. All right, so that was the instruction that was deadlocking me, I think. Okay, so where was I? Okay, so you first say what your... I mean, it looks as though I can do this. You first say what this value is. No, I think I'm going to want that. No, I think I'm... RG. No, wait, what? What am I doing? Too many things are happening at once. All right, let's go step by step. Read the right value, read the left value. This is left, this is right. This is also left now in the back buffer. Subtract that to do the comparison. If right is greater, then left needs to be subtracted from right. So let's just go straight over here. So left needs to be subtracted from right. So I need to take the right value and subtract left from it. Oh, I think I see. Okay, so if I were to swap, because I have that value saved in here, well, but I could also... Hold on, if I'm subtracting right from left already, then I can just negate that. By negating, I already have my value, and I just move that down. So I don't have to read anything else, so I might have to discard some I/O here. Okay, so RG is totally fine here. The non-RG path. If left is greater... this is just confusing me, go away. If left is greater, then... I need to subtract right from left, which I've already done. So just don't negate, right? So what I actually want to do is this. let's just say LG. Oops. Oh. Left is greater. Wait. 2 negates? No negate here. Negate only here, right? Ah! I like how short this is. You actually just want to be... Is it really that simple? I think so. Okay, well, I like how much shorter this got. Is it correct, though? No, let's let this tell me. That read way too many. What happened? Hold on. So yeah, things are going very wrong here. I don't know if the rest of my program is doing the right thing, but let's check on this one more time. So, read... I don't need this because I'm not using my back buffer. Read the left value. Subtract the right value from it. I know what's wrong here. I've lost the lesser value. That needs to be communicated somewhere. So I think the most reasonable way to do that is going to be to save something in your back buffer. This could be the lesser value. I don't know that it is. If left is greater, then I want to... save that in the back buffer, right? If it's not, something like this. Okay. It's weird that this is the part of the program that's giving me trouble, but I mean, I've already done this. I've already proven the concept in another part, and it's probably about to give me trouble when I go to debug it. This is the part that's new. So, again, high-level language. This is one line of very simple code. This is not a high-level language. So, read the left value. Save it. I might need that. I might not. Read the right value. Save it here. Send it twice. So, subtract right from left. If it's greater than 0, then that means left is greater. Okay, so I'll come back to here, but first let's go here. Discard this second value that's written. That's not right. Okay, I think I want to do the opposite of this. Okay, let's see if the opposite works. Okay, so subtract right from left. If you get a negative number, then that means right is greater than left. Yes. So you go down here, discard this, negate, move that value down, swap and write the left value, which was lesser, to this node. Yes. Okay. So if you get a positive number, you don't want this neg, then you want to, instead of discarding the value from here, you want to write it to the back buffer, which is what these commands do. Okay, and then go here, move the front buffer, which is the unnegated subtracted value down, then do the same thing. Right, at the point that you reach this instruction, at the point that you reach anything past here, your back buffer has the correct lesser value to write, which will subsequently be added to this, right? Okay, maybe? 708. 731, 717. What? None of those are even close to right. What have I done? Oh dear. Okay, so here starts the debugging nightmare. Okay. So first of all, are my numbers being communicated from here correctly? 765, that is correct. And you're going to send a 200, which is correct. So it seems like it. All right, 765 goes down here. 512 gets subtracted from it, giving you 253. It is greater than 0, so your bit is set. So you discard something from there, the second 512 coming in, okay? And then you tell this to JRow to here. You will add the bit. Great. Then you jump to loop. Cool. All right, so you added 256. Sounds good. Oh, I see what's wrong. My JRow is not discarding bits here. It's just opting not to add. That's the problem. So what I need here is to edit this. That's a problem. I'm not sure it's the only one. Then add 2 to my larger JRow offset. So instead of 0, you become 3. Sounds sane to me, right? Hey, there we go. Okay. That does seem to work. Okay. So cool. I applied a prior technique, learned some new stuff here, I guess. I feel like this should not have given me the amount of trouble it gave me, but, you know, all the little fiddly bits of things you have to do with register management and, you know, this language just means that this is what ends up happening. All right, let's see what I did. I'm at the low end of cycle count. Excellent. I'm not at the 100K end. Little high on the node count, which is fine. Little high on the instruction count, which is totally fine. Okay, so very similar statistics to this, which also used a very similar technique. Okay, makes sense. Neat. All right, well, I'm going to be happy for that with that. So yeah, next time I'm in the mood to pick apart somebody else's code, or like I finish a puzzle and have some extra time and just want to spend it on something, I'll actually dig into this and these and this other one at some point. All right, cool, but I'll see you next time for Submaximum Selector.